All right, let's go over again what a function is. A function is something that's being done to one set of numbers called the input, and then when you do something to it, you get out an output. For example, let's play a little charades. What kind of machine do you think is in the middle here? You got it? It is a washing machine, yes. So if we would take this over here, and you know what that is? Hopefully you do. It's a shirt, it's a dirty shirt. It's all dirty. If you put that in that washing machine, and the washing machine does its function, all right, it does what it's supposed to do, out comes what? Out comes another shirt. Now, it's the same shirt you put in, but this time it's sparkly clean. Come on, work for me here, pen. I'm running out of ink. Come on. It's all sparkly clean. So you put in input, a dirty shirt, its function happens, out comes an output. Well, in math, we talk about inputs and outputs are usually sets of numbers. So if I would slide this up here, one way to keep track of inputs and outputs is we use what some people call a function table. I call it a T-chart or a T-table. And the input usually is on the left-hand side, and it's the X. X is known as the input, and the other name we learned was the domain. So the domain is the input, which is the X. Now, it could be a different variable depending on what the problem is, but for now we use X. And then the output would be the Y's. Output, another name for output is range. So in a function, you put something in, you get something out. And a lot of times equations are used to show the function. For example, y equals x minus 1. If I put in a 5 as an input into that equation, into this function, the output is a 4. You put in a 3, you get a 2. You put in a 0, you get a negative 1. You put a negative 4 in, you get a negative 5. Now, the key to any function is for every input, there's exactly one output. One input goes to one output. And then what you can do with those inputs and outputs, you can write them as ordered pairs, right? You're familiar with those. And then every ordered pair, then you can take it and go to a coordinate plane, an x and y axis, and you can graph those. You can graph functions also. Now let's talk about what isn't a function. Is every equation going to be a function? No. Every equation has inputs and outputs, but sometimes an input can give more than one output. It could give 2 different outputs. It could give 3 different outputs. So the graph, when there's an x, it might have multiple points above it or below it where it has different y values or ordered pairs that have the same x but different y values. So let's take a look at a couple examples of ways we can represent functions, mappings, ordered pairs, graphs, T-charts, and see if we can identify which ones are functions and which ones are not. So in this page, we have what's called, there's many different types of ways to model or show relationships in math. In number 1, we have what's called mappings. These are mappings. And we're supposed to identify which one does not represent a function. So when I get these not problems, I take out the not and just read it. Which of these mappings does represent a function? So in letter A, in example A here, notice the inputs, the x is in this side of the map, and every input has exactly one output. Negative 1 goes to 2, 5 goes to 7, 10 goes to 2, 17 goes to 15, 29 goes to 2. Now, even though negative 1, 10, and 29 go to the same number, which is a 2, one input goes to exactly one output. So this is a function relationship, this first map. Now look at the second map, the B. Look at the input here. 11 goes to negative 7. 3 goes to negative 14. All right? And then you have 15 going to 2. And then you have 3 going to 18. And there's a problem with 3. Because you notice 3, that same input, actually has 2 different outputs. Right? So there's a 3 here, a 3 here. You can't have the same input going to 2 different outputs. Well, you can. It's just not a function. So this one would not be a function. If you looked at C and D, every input goes to exactly one output. So number one, when it asks which one is not a function, it would have been mapping B. Then it asks you a question, why? It says, why is your choice above not a function? A says at least one X value has more than one Y value paired to it. It's exactly what we saw. One X value has more than one Y. That can't be a function. One X, one Y, that is a function. B said each X value is associated with one Y value. Well, that would be a function. But in our question, it asks which one is not a function. C, there's only one Y value for each X value. That would be a function. D, each input is mapped to only one output. That would be a function. So in this one here, we're looking for not a function, and A would explain why B is not the function. Let's look at another one. Let's slide up here. So here we have a set of ordered pairs in number 2. Now remember, ordered pairs, the X is the input. Can only go to one output. And this question asks, each of the following sets of ordered pairs represents a function, except which one? So now we're going to identify which one is not a function and identify which ones are. So let me highlight in A, input. 17 is an input, goes to 4. 2 goes to 14. -4 goes to -5. Then we have a 17 again. And a 17 goes to 2 different outputs. That one is definitely not the function. Let's just check the other ones. B, -13 has a 5, -4 has a 0, 3 has a 5, +13 has a 21. Every input, one output, that's okay. In C, -2 and 11, 7, 11, and 19, each input has a different output. In D, -3 is -2, -1 is 0, 1 is 2, and 3 has a 4. One input, exactly one output. So reading the question carefully, we're looking for which one is the exception. Which one is not a function? This one here, because a 17 input can't have a 4 and it can't have a 17 being on -11. Can't have 2 different outputs. So why is your choice above not a function? Is it A, each X value is associated with one Y value? That would be a function. B says an input value is associated with different output values. An input, an X, is associated with different output values. That's exactly what happened. So the answer would be B. All right, last example, we'll go over some graphs. And in number 5, we're supposed to identify which of the following graphs represents a function. So one of these 4 choices is a function. Now remember, a function, one input goes with one output. And X, which is an input, can only have one Y. So if I go to graph A here, notice graph A here in like this purplish color. Think about the X-axis, which are these values right here. If I go to X is 1 right here, there is a point above it that has an output, which would be the Y value right here, like almost a +1 or 3/4 there. And then there also is a Y value that's a negative. That would not be a function because one input can't have 2 outputs. It would fail what's called the vertical line test, which the one video talked about. So that's definitely not a function. Look at B. Look how this graph is. If I pick this X right here, there is an ordered pair that has that X value, but it has this Y value. That would be the output. Then there's another point that would have another Y value, and the X would be exactly the same. So I should write the, that would be what, a -3, -1. Come on, pen tool. And up here, this would be a -3 and a +1. Same input, -3, different outputs. Can't be a function. It's a relationship, but it's not a functional relationship. So there's two graphs left. You can tell a circle would no way never be a function. Because if I looked at when x is 0, there's an ordered pair above here, this right here, and one down below with the same x value of 0. That would not be. But D, that is a function. For every x value, there's one ordered pair that has the x and a different y. Every ordered pair in here has an x, has a different y. There's the x value would be a 0, and it has a -1 y. One input, one output, that's going to be a function.